How's it going, stat students? This is Mr. Shack, and this is your Chapter 6 review video. Uh, this one takes a little bit, so to be honest with you, I'm going to be going really fast. I tried to drink a lot of coffee so that I can kind of rattle this off like the Energizer Bunny, but at the same time, I'm not going to be able to completely work out each problem. There's just no way that in a 30-minute video, again, that's my max, that's where I get cut off with this app that I use. There's no way I can just go through every problem thoroughly in 30 minutes. So I'm going to be trying to give you like the guided rundown of like what you're doing for each of these, what you're using, and how you're doing it. But this isn't going to be like a step by step, like you do this first and then this and then this, because there's just no way I could fit that in for each problem. So please use that or use this video knowing that. And don't expect to just get everything out of this video. There's no way you should be able to finish this whole review in 30 minutes. Like this video will have a length of around 30 minutes, but there's no way you're going to get through this entire review and understand it and be ready for your test in 30 minutes. So please realize that. Please take your time and understand that, okay? As we hop into number one, this was on your quiz as well. The best point estimate of the population mean is the sample mean. Not going to waste time with things like that. And like I said, it will be pretty fast for each of these. So when you're talking sample statistics, which level of confidence would produce the widest confidence interval? The larger the confidence, the larger the interval. Okay, so that would be D in that case. What is the effect on the width of the confidence interval when the sample size is increased? Well, as sample size increases, the width decreases. Okay, I believe that was on your quiz as well. Okay, if we are just finding the critical values for 99% confidence, remember that's when you're using inverse norm. And you're always doing center plus left tail. Well, it's 99% plus the left tail would be half of the 1% remaining, which would be a 0.05. So this is really like 0.99 plus 0.005, which does just come out to be the inverse norm of 0.995, which you should get 2.58. Okay, something like this, again, inverse norm, we're now doing 95%, which would be 0.95 plus 0.025, which comes out to 0.975. Okay, I did the math there that time. And you should get 1.96 there. Okay, let's keep moving. As you get into 6, again, the formulas are given to you, right? They might not be on listed by every single problem that you use it, but I can have that up on the boards, and maybe I'm recording this, when we're just starting chapter 5 right now, but those should probably be on the boards by the time you're watching this. And if they're not, just ask me. I can put formulas on the boards. So if there's something that's not on the boards that you want up there, just ask me and I will gladly put it up there. Okay, so find the maximal margin of error. E equals the critical value times sig over n. Okay, they're giving you the critical value. You're not having to use inverse norm or anything. They're just giving you that. So you're literally just plugging and chugging here, saying 0.8. Okay, and then sigma is 1.3 over square root of your n, which is 75. When you work that out, again, you should get 0.12, and that could, working that out really can be as simple as just throwing that in your calculator. Again, I do have the answer key sitting next to me, so I'm going to be explaining how you're doing these, but I've already worked them out so that I can hopefully get this whole video in a timely manner. Okay, construct a 95% confidence interval for the mean number of sentences in magazine ads. If x is 10.4, x bar is 10.4, so that's your sample mean, and the margin of error is 1.4. Okay, so if you're using a confidence interval, you're using that x bar to estimate your population mean using your sample mean. Okay, and they already give you it's a 95% confident interval, but they already gave you your e's. So you're just doing, the low bound is going to be 10.4 minus 1.4, that's 9, and then 10.4 plus 1.4 is going to be your upper bound, which is 11.8, and that's all there is to it. Okay, that's all you're doing for something like number 7. As you go on to 8, find the 95% confidence interval for the mean number of sentences in all magazine ads. Again, if x bar is 23.2, sig is 2, and now n is 50. Well, in this case, they don't give you e. So you first have to find e and realize, okay, it's a 95% confidence, so I'm having to do inverse norm of that 0.95 plus its left tail, which is 0.025, which, a lot of us at this point realize like that's just inverse norm of 0.975. Either way, you get 1.96. Okay, that's your critical value. That's your critical value that you're using. And you're using this formula, oops, you can barely see it, this formula still for E. So that is going to be 1.96 times sig, which is 2 over the square root of n, which is 50. Okay, so that's the formula you should be using to get your E, your margin of error, which is 0.55. That's what that comes out to. Okay, and then you are using that to say, okay, if my x bar is 23.2, the low bound is 23.2 minus my margin of error, and the upper bound is 23.2 plus my margin of error, which, when you do the math there, you get 23.75 for your upper, 22.65 for your lower. Okay, there's your 95% confidence interval for a problem like that. Okay, moving on to the second page. I think I'm making good time, but honestly, that first page probably is the page that should go the quickest. Maybe the last page too. These middle two pages, they take a while. Okay, but at this point, you've done this Walter problem. I think at least a few times because I think it was on your quiz. I think it was on a worksheet or possibly two. So when you're looking at this and you're saying, okay, we got sigma being 2.4, we got x bar being 22.5, got a sample of 90, so that tells me n is 90, and that pretty much covers everything. We're finding a 99% confidence interval. So first, to find your critical value, you're doing inverse norm of that 0.995, which again is your center plus left tail. You can think of it as 0.99 plus 0.005. Either way, you get 2.58. We actually already calculated that, the critical value for 99% confidence. We did that on the front page already, and you got 2.58. Okay. Is the X bar distribution approximately normal? Well, n is 90, so yes. Okay, so yes, n is greater than 30, right? And that's what the central limit theorem, that's what we're using here. The central limit theorem says if it's greater than 30, greater than or equal to 30 for your sample size, then it will be approximately normal. So that's what you're using there. To find your value of E, again, I'm not even going to write this one all out. We've done this problem multiple times on a worksheet. I believe you did it on your quiz. You should get 0.68. Okay. So this one, I'm really just going to go through fast because we've already done this problem multiple times. Once you get your E, then okay, you're going to do your mean, which is 22.5 minus that 0.68, and then you do the 22.5 plus the 0.68 down here. Okay, and well, what do you get? You get 21.85, and you get 23.15. Okay. Which means we are 99% confident that the interval from 21.85 to 23.15 is an interval that contains your population mean. Okay, that's how you would put that into words. You're just having to fill in the blanks there, so that should not be too bad. Again, we've done this one multiple times. For this one, you're doing the 2.58 times your sigma 2.4 over the square root of 90. Again, that's how I got the 0.68, but we did that multiple times, which is why I kind of felt I could go fast through it. Okay, that problem has come up quite a bit. As we go to 10, a sample of the reading scores of 35 fifth graders. Okay, we got 35 fifth graders. That tells me n is 35 right away. It has a mean of 82. Again, this is a sample mean, so that x bar is 82, not 81. Standard deviation of the population is 15. Okay, so they give us that sigma is 15. Okay. Find the point estimate of the mean. Okay, well, that's the sample mean, which is 82. We use x bar for our point estimate of the population mean. Sample mean is 82, so that's our point estimate. Find the 95% confidence interval of the mean reading scores of all fifth graders. Okay, 95% confidence. That's first having to do inverse norm of, again, center plus left tail, which would be 0.95 plus 0.025, which again is 0.975, which comes out to 1.96. Okay, so that's your critical value. That's your critical value. And then you're doing that times sigma over the square root of n. So I'm just going to hop right into that. Times your sigma, which is 15, over the square root of your n, which your n is 35. Okay, again, this is doing, okay, that's our critical value. That formula is still where it's your critical value times sigma over the square root of your n. Okay, that's where those numbers are coming from. And when you work that out, you should get a margin of error, an E of 4.97. Okay, 4.97. So when you take your lower bound, you're using that point estimate, that mean of 82, and you are subtracting 4.97 from that for your lower. You should get 77.03. You take 82 and you add that margin of error, 4.97, to get your upper, and that's where you should get 86.97. Okay, so there is your 95% confidence interval. Now it's saying, okay, find the 99% confidence interval. Well, what that is changing, that just changes your Z, your critical value to 2.58. Okay, why 2.58? Again, this is actually the third time we're finding that critical value for a 99% confidence interval, because we did it right up here, and then we did it on the front page as well. So that's where the 2.58 is coming from. It's the inverse norm of 0.995. Okay, so we got that, and it's really just, okay, now same exact formula, except instead of the 1.96, you are replacing it with 2.58. And when you do that, your margin of error should be 6.54. Okay, again, using exactly this, just instead of the 1.96, you are putting in the 2.58 instead of the 1.96. That's how I get that E. Okay, and then same thing here. You're still using that point estimate of the sample mean being 82, and you're minusing the 6.54 for your lower bound, and you are adding the 6.54 for your upper bound. So you should get 88.54 here, and you should get 75.46. Okay, so which interval is larger? Well, you can look. This one goes from 75.5 to 88.5. This one goes from about 77 to about 87. Okay, so these are 10 apart. These are more like 13 apart. So which interval is larger? 99% is larger, because it's the larger confidence interval. Okay, and the interval is always sorry, I can't talk and write at the same time, because larger confidence interval. Okay, so always, the larger the confidence, the larger the interval. Okay, larger the confidence, larger the interval. When the population standard deviation, I'm looking at 11 now, is unknown and the sample size is less than 30, okay, so no sigma, that means sample size is less than 30, what table value should be used in computing the confidence interval for a mean? Okay, that's when you're using your T interval. Okay, so you're less than 30 and you don't have your population standard deviation, that's when you go to your T interval. Okay. The blank are the number of free choices left after a sample statistic such as X is calculated. Okay, the giveaway here is free choices. That should have alarms going off in your head that we're talking about degrees of freedom. Okay, again, kind of a weird concept, but it's basically saying, like, once you have one of the statistics, for example, X bar, like they're saying, so that's removed. So that's why it's n minus 1. And that's degrees of freedom. But if you're like, okay, I don't understand what you just said, well, then just the free kind of gives that away. We're talking about degrees of freedom, and those go hand in hand with T intervals. Okay. Going to 13. In this case, you are given, okay, we got a T interval. and we have a sample size of 10 here, right? But we could have, like it says that here, but we also could have counted and realized, okay, there's 10 numbers here. Estimate the true mean price, which means we need the sample mean first. So to find your sample mean, remember you're adding all of these up and you are dividing by the total of number there is. So when you add all of these up, you should get 2,177. Then you are dividing that by 10. So you should get 217.7. That's your point estimate. That is your sample mean. Okay, this is your X bar. That's important. Okay, that's your X bar. And you are having to calculate that on your own. But again, we've been calculating means since chapter 2. Just add up all your values, divide by however many there are. And really, you've been finding means since middle school, maybe even before that. So when you're looking at this now and you're saying, okay, I got to use this this sample mean now to find my confidence interval. Okay, well, we need the margin of error. Anytime you're doing a confidence interval, you need the margin of error. This is a t interval, so you're using your t critical value, which will always be given to you. That's this 2.62. Okay, that's your t critical value, and then it's s over square root of n, which again is just because we don't have the population mean, so you have to use your sample standard deviation. Now the thing here, this problem does not give you your sample standard deviation, but it should, and on your test it will. So this should be given to you that your sample standard deviation, is just 17.49, not 1.49, or not 0.149. It is just 17.49. Okay, that will be given to you on your test. So I'm giving it to you now. Just say, let's use the sample standard deviation of 17.49. We have n being 10. So what this should look like is you use your t critical value, which is 2.262, and then you're multiplying that by the 17.49. That's your s over the square root of your sample size, which is 10. Okay, this should come out to 12.5. Okay, that's what your E, your margin of error, comes out to. So then here you're using your X bar, your sample mean, and your low bound is going to be that sample mean of 217.7 minus the 12.5. Your upper bound is going to be the 217.7 plus the 12.5. Again, I know I'm going really fast. I feel like I'm talking a million miles per hour. The nice thing about YouTube videos is you can slow them down, you can pause them, you can rewind them. So use those functions. Okay, I just have to get this in because it would suck to get cut off because I didn't get everything in my 30 minutes. So going to 14. As we go to 14, we are again given a bunch of values. It looks to be 7 values, so n is 7 here. Find the 99% confidence interval for the mean shoulder height, or for mu, the mean shoulder height of the entire population of such horses, S equals 1.19. Okay, so this, again, they're giving you your sample standard deviation, which is what should have happened here. Okay, you have to add all these up and divide by your sample size of 7 again, just like we did in the previous, because the X bar is not given to you. So you have to find it on your own by adding these up, dividing by 7. You should get 46.14. Okay. Ooh. From there, you are talking degrees of freedom. Okay. Degrees of freedom, that's always n minus 1. So if n is 7, you're just doing 7 minus 1, and that's 6, and boom, you should get a free point just like that. Okay. And then they're giving us the t critical value of 3.707. So we need to use this formula and say, okay, I'm doing 3.707 times s, which they give us as 1.19, over the square root of n, which n is 7. Okay, when you do that, you should get your margin of error as being 1.67. Okay, so then you're going to do 46.14, that's our sample mean, minus that 1.67 to get your lower bound, which is 44.47. And then you're going to add it, you're going to do 46.14 plus the 1.67 to get your upper bound, and that is 47.81. Okay, there is your 99% confident interval for something like that. Okay, 10, randomly selected. That tells us n is 10 here right away in number 15. The mean time was 7.1. Okay, that is our x bar being 7.1. I'm just going to write all these out here. And the standard deviation was 0.78. So S is 0.78. We are finding the 95% confidence interval of the mean time. Okay, first off, degrees of freedom. Always your n minus 1. So that's 10 minus 1, that's 9. Okay, then they give us the t critical value, so we are just doing 2.262 using their formula here, right? And multiplying that by your s, which is 0.78 over the square root of 10. That is all you are doing for b. Again, we've been doing this formula many times throughout this review already and many times throughout this unit. You should get 0.56. That's your margin of error. So you take your x bar, which is 7.1, that's your sample mean. You're going to subtract your margin of error for your low bound. And once again, you're going to add your margin of error, 0.56, for your upper bound. Okay, so your upper bound should be 7.66. Your lower bound should be 6.54. Okay, as we get to D, one can be 99% confident that the population mean is between these two. Okay, it's just another free point basically saying like, hey, let's put this into words, and they basically put it into words for you, and you just fill in the blanks with your two blanks from up here. Okay, the point estimate P, the population of success, is P hat. Okay, and what is the formula for P hat? That is X over N. Okay, it's just asking you what's the formula for P hat? It's X over N. Last page. I think we're doing okay on time. Hopefully I don't get cut off. So let's get right into it. What is the point estimate for P if we have a random sample of 188 books at a local bookstore, and they showed that 66 of the books were murder mysteries? Okay, P hat is going to be the 66 murder mysteries out of the 188, which comes out to be 0.35. That's your P hat. Okay. Once you have that, well, then you also really have Q hat, because it's always going to be 1 minus whatever your P hat is, which that's 1 minus 0.35. So that means Q hat is 0.65. Okay, Q hat is 0.65 there, P hat 0.35. That's really all we need to be able to go ahead and do this. Find a 90% interval for P. Okay, first off, 90% interval. We haven't done a 90% yet on this entire review. So we got to do inverse norm of center plus left tail. That's 0.9 plus 0.05, which is really just inverse norm of 0.95. Okay, and you should get 1.645 there. Okay, so that's going to be your Z critical value. Okay, so in the end, we're going to be saying like P has to be between these two values. And I'm just going to write this out once, because once we're going to subtract it from P hat. So going along here, we got 0.35. And for the low bound, we're going to subtract from P hat. But for the upper bound, we're going to add this to P hat. So I'm just going to write it out once and say like we're going to do plus and minus. The plus is going to be your upper, the minus is your lower. And what is it? Okay, we got your Z critical value, which we just found to be 1.645. Okay, all times the square root of P hat, which is 0.35. Ooh, I'm going to run out of room. Times 0.65 for our Q hat. Okay, we barely fit it. All over N, where your N is the 188 total books. Okay, N is the 188, not 18S. Okay, this is your N being 188. Okay, so again, you will do the 1.645, multiply it times the square root of 0.35 times 0.65 over 188. Again, it's the square root of all of that. And when you do that correctly, your lower bound again is 0.35 minus what you get there, which you should get 0.2938. And your upper bound would be 0.35 plus what you get here, which should be 0.4083. Okay, that is finding your P interval. Okay, doing the exact same thing for this next one. We just have a little bit of a different problem. They're giving us the 15.9% of individuals purchase religious books at a Christian bookstore. Okay, find the 95% confidence interval of the true proportion. They're giving us P hat right here. That 15.9% is our P hat. That's 0.159. which means Q hat would just be 1 minus the 0.159, which is 0.841. Okay, from there, we're finding the 95% confidence interval. So again, that's inverse norm of 0.975. What is that? That's 1.96. Okay, that's 1.96. We found that a couple times. And then you're using the same formula that we did just on the last one, which means take your p hat, which is 0.159. For your lower bound, you're going to subtract it from a bunch of stuff, and for your upper bound, you're going to subtract it add it to that bunch of stuff. And that bunch of stuff is your critical value, which is 1.96, times the square root of p hat, which is 0.159, times q hat, which is 0.841, all over your n, which in this case, your n is the 1721 total people. Okay, again, so you're having to do this part, everything after this plus minus, do this first, okay? That's what is needing to be calculated first, and then your lower bound will be the 0.159 minus that, which you should get 0.14, and your upper bound should be the 0.159 plus whatever you get when you calculate all of this. Again, if you have questions about like, oh, I'm not getting that, I must be putting it in my calculator wrong, okay, that's something, talk to me in person about. Okay, very lastly, use the confidence interval to find the point estimate and the margin of error. To use an interval to find the point estimate, you're just going to average the two. Okay, you are just averaging the two. So I'm doing 0.264 plus 0.494. You're averaging your lower and upper bound, which means you add them and you divide them by 2. What you get when you do that should be 0.379. That's your point estimate. Add the bounds of your interval and divide by 2. Lastly, the margin of error then, well, if your point estimate is 0.379, I then take my upper bound of 0.494 and I subtract that 0.379 to find what that margin of error is, and I get 0.115. All right, so that is your chapter 6 review video. That's a lot there. I know I went fast. Hopefully you use that pause button, use the slow down button. Again, you're not going to understand that full review in the 30 minutes or however long this video ends up being. So please make sure you take your time to really understand all of this. Please talk to me, ask me questions if you're unsure about how you're putting something in your calculator. I know I didn't show those parts, but hopefully that was helpful. Good luck on your test, and I will catch you guys later.